I was a little bit surprised to see this question considering it has the cube, which generally doesn't show up on the GMAT. So some of you might know that this will expand to n cubed plus 3n squared plus 3n plus 1. And honestly, I mean, I've seen this a lot of times, but I actually keep forgetting. So in the exam, I actually ended up doing the square first and then multiplying this. So this would be n cubed because I didn't want to take a chance with making a mistake. So some of you may have to do that as well. So I was a little surprised. Usually they don't ask cubic questions, but maybe there's another way to think about it, at least, because there's nothing you can factor here. And I think plugging in the answer choices was also kind of not clear because if, for example, n is 6, a lot of us might be tempted to do that, then it's this form, whereas the answer choices are products. So we have a minus here. So that one doesn't work either, but I think I ended up doing this expansion, and then you're subtracting n cubed and 1. So we know that those drop out. I'm left with 3n squared plus 3n. Whenever I see that on the GMAT, I'm going to factor 3n times n plus 1. And then glancing at the answer choices, I realize that if n is 31, this is 3 times 31 times 32. So then the answer is D. Now, at the moment, I don't know how else, if there's another method, even using the answer choices. I'll keep thinking about it and see if there is another way to kind of approach this. But just kind of using the answer choices was kind of hard, at least. But I mean, you can certainly eliminate some of the answer choices by doing that. But I think the method that makes sense to me is doing this expansion. So that clearly means that it might be helpful to know this cubic expansion. That will save you some time, but worst case, you can always do that. So to summarize, the answer is D.